this example, we've got the natural log of sine of x. So that's kind of interesting, right? When we asked about the domain here, because it's got natural log, right? You know you can't have natural log of a negative number or of 0. So we need sine of x to be strictly positive, okay? So what values of sine of x are strictly positive, right? If I look at my unit circle, the sine is the y coordinate, so it's going to be values between 0 and pi, right? But not at 0 or pi. So we have 0 and pi. But then, of course, this is periodic. So I'm also, if I go back another again, I'm going to have between 2 pi and 3 pi. And then, again, between 4 pi and 5 pi, right? And then on the other side, right, because I have to think about possible negative values too, right? So it would then, if I'm going the backwards, right? Now my unit circle's in the way. From 0 to negative pi, it's no good, but it would be from negative 2 pi to negative pi. So basically you have this situation where you've got a chopped up domain, where you have areas where there's no graph, and then areas where there is a graph. But they didn't give you they didn't specify the domain. So if they don't specify the domain, you have to list all that stuff. Okay? Right. So really, how am I going to write this? I can write it as 2n pi to 2n plus 1 pi, right? Because it's always going to be the even one to the odd one. Okay? So well, we'll just write it this way. Uh, 0 pi union 2 pi 3 pi union blah blah blah. All right, whatever, anyway, all those guys. So that's kind of an interesting situation. Now when sine goes to 0, though, when sine approaches 0, which is going to happen whenever x approaches any of these endpoints, you're going to have the natural log of something, right? So you're going to have natural log approaching 0, right? So you are going to have asymptotes, vertical asymptotes at each value of n pi, right? Because my function here is going to be approaching 0, so natural log is going to be going to negative infinity, right? Okay, so let's write that down in a little bit better way. So let's concentrate just on the first one for a minute. Limit as x goes to 0 from the left of natural log of sine x. This is going to be like natural log of 0, which goes to negative infinity. And then the same thing is going to happen on the right-hand side of my interval, right? Did that wrong. Should be like this. Sorry. Natural log of sine x. Again, we're going to be doing natural log of 0, so this is going to be negative infinity. And the same thing is going to happen for each of these. So it's kind of like secant, but not really, because you're always going to be approaching negative infinity. Okay. So we'll keep that in mind. So limit, I'm just going to write it, limit at vertical asymptotes is negative infinity. I would, if I had space, draw it, but let's just write it there and then we'll draw it later. Now we have to do intervals of increase and decrease, maximum, etc. So derivative of natural logs are going to be 1 over sine x times the derivative of sine x, which is cosine x, right? Okay, however, so basically this is cotangent, right? So let's see though what happens. Where is it 0? Of course it's going to be 0 here where our asymptotes are. So let me just pay it, well, yeah, okay. Let's just do the one from 0 to pi, recognizing that this is going to basically do the same thing. So I'm going to focus from 0 to pi for my picture of my graph. And then we'll put the rest together with the fact that it's going to be periodic, right? Because as I go into the next one, right, it's just going to be the same value. So you're going to have a periodicity here because of the fact that sine x is periodic. It's just periodic in a weird way because it's a natural log of it. So I'm going to focus first and then extend, because otherwise it'll be a big mess. Okay, so I know that the ends of my interval are 0, pi. And then where is this going to be 0, right? F prime of x is 0, where cosine of x is 0, or x equals pi over 2. So I have that point on there. And then if I look at this, between 0 and pi, sine x is always positive, right? Because on our domain, sine x is always going to be positive. So I'm just going to be looking at the value of cosine. So this is positive, this is negative. That's going to tell me that my value of pi over 2, right, is going to be a maximum. Okay? So I'm just going to pick the first one, focus on that, and then later I'll extend it. So on interval from 0 to pi, we have increasing from 0 to pi over 2, decreasing from pi over 2 to pi. We have no min, and our max is at what? Pi over 2 and what? Let's put it in. F of pi over 2 is natural log of sine of pi over 2. That's natural log of 1. That's 0. Okay? So that's the maximum. Okay? Now, concavity. So the second derivative, okay, if I really want to be, this is cotangent, right? So the second derivative is minus cotangent x cosecant x. So minus sine squared on the bottom. Okay. This seems funky, but all right. Derivative of cosecant. Okay, so let's see what happens. Again, we have basically the same situation though, right? Because I've got the minus pi to pi, and pi over 2 is going to give me a 0 on the top. But let's see what happens when I make my sign chart. Okay, so if I'm going from 0 to pi over 2, cosine is positive, sine is positive, this whole thing is going to be negative. If I'm going, this is something weird here. What did I do? It is not supposed to be, the whole thing is supposed to be concave down. If I did something, so cotangent, cosine over sine is sine squared. Oh, the wrong one. The derivative's wrong. Ha! I knew there was something wrong. Cotangent, the derivative of cotangent is cosecant squared. Bonus to everybody who noticed it before I did. I did the derivative wrong. Woo! All right. Then we don't have this point. Yeah, it didn't really make any sense there. That didn't make sense to me. So all we have is these two. This, of course, is going to be negative everywhere. So concave down over the whole interval, no points of inflection. All right. So now let's kind of put this together. Okay, this is going to be pi, 2 pi, 3 pi. Right, because I said I have to extend. It didn't tell me I just had to graph it between minus pi and pi. Okay, I mean 0 and pi. So here's 0 pi. These are my asymptotes. I have one point of interest, which is the max, which is just going to be 0 here. And these are all going down to infinity. So it's going to look like that. Okay? Now, then that makes sense. Now, to what extent does it make sense? Remember that the natural log, if I think about the natural log function, right? Natural log function looks like this. Between 0 and 1, it's always going to be negative. So it makes sense that our values are all negative here because I have to have sin x always goes between minus 1 and 1, but I didn't have absolute values here. It wasn't given with absolute values. It was just given this way. So this is what I have. Now, between pi and 2 pi, I have no function because it's not on the domain. I can't. So between 2 pi and 3 pi, though, I have exactly the same picture. So this is pi over 2. This is 5 pi over 2. And then nothing here. And then again, we're going to have this here. This is going to be what, minus 3 pi over 2? Okay. So this is what the graph is going to look like. So we know, and how do I know it's going to look like this, right? I knew I was able to graph this, but how did I figure out the rest of it? Well, basically, the figuring out the rest of it comes exactly from the fact that sine of x has a 2 pi periodicity, right? So if I think about sine being periodic between 0 and 2 pi, what's happened here is that I've taken the whole graph from 0 to 2 pi and put it over here and put it over here and sort of extend it that way. There happens to be no points in the graph in this bar because in that bar between pi and 2 pi, sine is negative, so I had to throw that out of my domain. That's okay. So, but that part where there's nothing then also gets moved over because that's part of the periodic thing about your sine function. Okay? And etc. I'm just going to put and etc. here. If this was on a test or on the worksheet or something, it would be fine for you to just describe this process the way I did. I wouldn't require that you come up with like you can come up with this as being n in regular, like, what am I trying to say? Like, come up with what these numbers are, right? They're like 4n plus 1 over 2, right? But you don't need to worry about it. Just describe the process so you understand what's going on, and that's the most important thing.